Hello guys, welcome to Physics Mastery Academy. Today we are going to answer part B, C and D of this question. The diagram below shows some of the equipotentials in a plane perpendicular to two parallel charged metal cylinders. The potential of each line is labeled. Part B. On the diagram, sketch lines to describe the electric field produced by the charged cylinders. Before we work on this electrostatic system, let's generalize our discussion. The electric field of a positive charge always points directly away from the charge, like this. And by definition, equipotential lines are perpendicular to the electric field lines, like this for V1, this for V2, for V3, and so on. So, as you can see, all these circles are perpendicular to the electric field lines. For example, some random locations like these ones. As you can see, electric field and equipotential line cross each other at right angle. Also here, right angle, and also there. And at any location that you want on these spheres or circles, the electric field cross the equipotential lines at right angle. Now let's go back to our question. So the electric field for these two positive charge should cross these equipotential lines perpendicularly, like this. And again, I can show you at random locations like these ones to see how the electric field cross equipotential lines at right angles. This one, this, and at any location. This is for part B. Now let's focus on part C. It says, determine the potential difference VA minus VB between points A and B. VA is minus 20 volts, as you can see here, and VB is minus 10. All points on this line have the same potential, like point A, that all points on this line have minus 20 volts potential. The difference between VA and VB becomes minus 20 minus 10. But it becomes minus 20 plus 10, this part. And ultimately, we get the voltage difference between point A and point B as minus 10 volts. Now we are going to answer part D. How much work is done by the field if a charge of 0.5 Coulomb is moved along a path from point A to point E and then to point D? This point is A, E, and then D. Electric charge is 0.5 Coulomb. VA is minus 20 volts, as you can see on this equipotential line, and VE is also minus 20 volts because A and E are in one equipotential line, and VD is 10 volts. Let's first find the work from A to E. We can find such a work by this formula. VE and VA are the same, minus 20 volts. If we substitute voltages in this equation, we get this, and regardless what the charge Q is, the result will be 0. In other words, no work is required to move a charge along an equipotential line. So when we move from A to any other points on this line, we don't do any work because electric field is perpendicular to this path. Therefore, no work is done when a charge moves on an equipotential line. The second part of this question is the work from E to D. If we substitute VD and VE and Q, we get minus 0.5 times 10 plus 20, and we get minus 15 joules. Therefore, the required work to move 0.5 Coulomb charge from point E to point D is minus 15 joules. Thank you for watching this video.